Thank you, guys. Okay, welcome to my presentation. My name is Sarcina Zhu from Sarcina Technology. I used to work at Intel and DEC many years ago. We're going to talk about the driving force for the advanced packaging, and we're going to talk about the bump pitch transformer. That is the key component of the advanced packaging, and that provides the hardware for today's all high performance computing devices. And then we're going to play a very short video for FOCoS B technology. You can see very interesting. And then we're going to talk about the services that our company could provide and why Keysight EDA softwares are so important for our company. Okay. Here's a pop quiz. What is the common denominator across artificial intelligence, quantum computing, and autonomous driving? Some people will say probably the advanced silicon technology node. Right, you go to 3 nanometer, 2 nanometer. That is the most important. Packaging, good. One reason is if you look at quantum computing, there's no CMOS. Okay, they use a qubit, quantum bit. Right, if there's no CMOS and no silicon, then there's no wafer foundry. Sorry, but the advanced packaging has to be there for every device, every high-performance device. Okay, if you go back 77 years ago to 1947, where the first transistor was invented at AT&T Bell Labs, right? Starting from time 0, you're going to see, over the times, several top companies, they offered key products for their company to make their company #1 in the high-tech industry. Every product actually used the advanced packaging. 1980, this is the IBM mainframe, right? They used the multi-chip module. 1999, Intel used the organic flip chip substrate to replace the very expensive ceramic substrate. Okay, 2000, Intel put 2 microprocessors side by side inside a package to increase the performance of its server chips, right? And then the offset, they use stacked dies for cell phone applications in 2000. Okay, at 2011, Xilinx and TSMC, they did 2.5D silicon interposer. Right, this becomes very famous. That becomes the foundation of today's high performance computing devices. Okay, so today, we have several companies. They are offering 2.5D packaging solutions, but they're all used for high-performance computing applications and communication applications, especially artificial intelligence, right, and autonomous driving. Okay, if you look at this chart, it is very interesting. The packaging industry, right, has enjoyed the top 2 curves. Right, over the times, we're using the wire-bond technology, we're using the flip chip technology for organic build-up substrate, ceramic substrate. They enjoyed it for decades, right? But at 2010, right, and one company was not happy about this. That is Xilinx. Right, and they found out that this packaging technology is not enough. So they, worked with TSMC to come up with the silicon interposer technology. Then, starting from that time, there's a rapid drop in the bump pitch. right? Through silicon TSV interposers and also silicon bridges. Okay, so this is the start of the time when the fab guys, the silicon guys, started to get into the packaging industry, okay, for the benefit of their product and the wafer foundry business. Okay. Here there are 3 columns. You can see 3 types of bump pitch transformer technologies, right? From TSMC and Intel, right? And the last one is from ASE and SPIL, okay, ASE group. So what I wanted to point out is, for Intel's technology is mainly used for Intel internal customers, their internal microprocessors. Okay, for TSMC is mainly used for their strategic key customers, right? But today, it is the first time that this technology is available to anybody, any company on the planet. So that is very important. All the small companies, all the mid-sized companies, before there's no food, you can only daydreaming, okay? Today, you can use this technology to design your own AI chips. So that is very important, okay? Another thing I want to mention is, today people are very focused on high-performance computing. Actually, high-performance communication is also very important. If you look at the data center, what is the most cost-effective, stuff, right? The chips from NVIDIA is very important. But the chip-to-chip interconnection through photonic IC, through silicon fiber to the silicon die, that is also very important. Okay, the FOCoS B, okay, fan-out chip-on-substrate for silicon bridge packaging technologies, right? There are many technologies. Here, what I want to say is because of the availability of this manufacturing technology to anybody, to every company on the planet, so the design of your devices using this technology becomes very important, okay? And our company can help out, actually, okay? Here, I wanted to play a video.
The biggest advantage of fan-out packages is to achieve homogeneous and heterogeneous chip integration. 2 chips from different wafers are attached onto a carrier wafer based on the designed functional partitioning. After molding encapsulation, the reconstituted wafer is formed. With wafer staying face-up, wafer-level redistribution layer and C4 bump process continues for intra and inter-chip across this reconstituted wafer. After the fan-out chip is flipped onto the substrate with reflow, the assembly of a fan-out chip on substrate is done. The pitch and size of C4 bump is significantly smaller than solder ball. The multi-layer fine line of RDL is much thinner than the substrate trace. These features make fan-out ideal for various applications, from client devices to infrastructure and high-performance cloud computing. Even fit for emerging applications such as VR/AR, autonomous driving, and artificial intelligence.
I think now everybody is a professor of this technology. You can go to your, company to teach. Our company's bump pitch transformer, service offerings. First of all, we had the experience designing a 2.5D silicon interposer package 6 years ago. Here's a picture of the package. You can see there's one ASIC, a 2 HBM1 at that time. using this kind of technology today, we can design the bump pitch interposer transformers. We can insert the open short test patterns and also do the package design, PISS thermal simulation, and all the rest of the stuff. Okay, this is a very important page. Okay, before you tape out such a advanced, complicated systems, right? How do you know it's going to work? The only way to do that today is to run the system level channel simulation, right? For both PI and SI. I skipped the PI. Here I show the signal integrity. You can see, for 112G, PAM430s, for 56G PAM4 DDR, we are all using Keysight ADS and memory designer tools to validate the design. Then we tape out. Here's the summary. Okay, HPC performance really need the help from advanced packaging, right? The bump pitch transformer is the most important component of this advanced packaging, and this technology is available today. And we can design it for you, we can manufacture it for you, and you can test it and use it in your lab. Okay, the pack design requires expertise, and we have the resources and the tools, okay, from Keysight and some other vendors to do this successfully. Thank you.